So now we're going to talk about the different types of systems of linear equations in two variables. So there's three kinds, and we've already alluded to this. You could have one line and another line where they intersect at one point. This means there's one solution, and that's exciting. So we've had lines like that. I'll put little arrows. Okay, you could have a line and then another line, and they're parallel. So these are parallel lines. And then you're going to get no solution. This system is said to be inconsistent. All right. And then you could have something like this. Let's say you have the equation x plus y equals 3. And then you have another equation, 2x plus 2y equals 6. Well, can you see that they're really the same equation? Because if you take that bottom equation and divide everything by 2, which you're allowed to do, you'd have the top equation. So you don't really have two lines at all. You just have one line. So you can graph the line. So, here's the line, but you don't really have two lines. And so it's the same line or identical lines, or you just have one line. Okay, so they're the same line. Okay. Then you have infinitely many solutions. And the solutions are all the solutions that make up that line. This is said to be a dependent system. Dependent. Okay, I can't spell dependent. Dependent. Okay. Now, oh, I misspelled consistent too. Okay, consistent. Inconsistent. This system is consistent. It's just dependent. And this system is also consistent and independent. Consistent is why I abbreviate everything. And it's independent. I don't think they use that a lot, independent. But when there's no solution, when you have an inconsistent system, you're going to say no solution or the empty set. Okay? When you have infinitely many solutions, there's a couple ways you can write it. You can just write the line. So whatever the line is, that's your solution. And then if you have one solution, you're going to get an ordered pair. Okay? That'll be your solution. All right. So let's see if what happens with this next system. I've got 4x plus 6y equals 12 and 6x plus 9y equals 12. Okay. Well, I'm thinking I want to eliminate something. So I'm going to go for the x's. The numbers are a little bit smaller. So I'm going to multiply the top equation. Let's see, what do 4 and 6 both go into? 12. So I'm going to do the top one by a -3 and the bottom one by a 2. Okay, and that'll get me a -12 and a 12. So that's the part you have to really stop and think about. I kind of did that fast, but I'm thinking about a number that both 4 and 6 will go into. I came up with 12, and I want one to be negative and one to be positive. Okay, so I get, after I distribute, I get -12x minus 18y equals -36. And then in the bottom, I get 12x plus 18y equals 24. Okay, well, I can tell something's going to happen. When I add these equations, I was hoping to eliminate the x's, but look, y is eliminated also. That means I have nothing on the left-hand side. I have 0 equals, and then what do I have on the right-hand side? And this is what matters. I get a -12. Okay, now, this is not true. Not true. That means that this is inconsistent. And it means there's no solution. Okay? So those were parallel lines. So when everything drops out on the left-hand side, that's okay. It means one of two things. Either you have an infinite number of solutions or you have no solution. If your statement 0 equals negative 12, if that's not true, then there's no solution. Now, if it had come out 0 equals 0, that would have been true. That would have been the dependent system. Okay, I'm sure we'll see one of those.